The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. Inside Analysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com. InsideAnalysis.com. And now, here's your host, Eric Kavanaugh.
Oh, yes, indeed, folks. Welcome to the future. And yours truly, Eric Kavanaugh, is here for the only coast to coast radio show all about the information economy, Inside Analysis. And we're going to be talking with an expert about one of the most important things in business today, the network. Yes, the network. We all know when the network is slow, everyone knows when that happens, and that's no fun at all. I saw a great meme a while ago that said something like, if you want to find out who you're dealing with, put them on a really slow internet connection for an hour and just see how they respond. Because that's going to tell just how patient a person you are. You never go back, right? Once you get things faster, you can't go back to having them slower. I remember the old days with AOL. A friend of mine said, "Oh, get on AOL." I really didn't want to do it. I did it anyway, and like downloading images. Then when I tried to get off of it, like 6 months later, they're like, "Oh, what credit card did you use to log on to?" I'm like, "I don't remember, dude. I just want to get off this service." But that's the old days. Things are better now. And since we're going to be talking about networking with Tiffany from a very cool company called Red Bison, I figured I'd throw out my one bad, terrible networking story from the early days in Seattle at TDWI. They went out and they bought that VoIP stuff, and it was just awful. And I noticed it would get worse throughout the call. So if you're on a call for like 30 minutes or 40 minutes, like 40 minutes in, man, it's like, like all that kind of stuff. You're just like, oh. I remember talking to management saying, "Guys, don't you think it's important that we be able to communicate to people outside the company as kind of a critical component of information sharing?" But anyway, things are so much better these days. And Tiffany, you know a few things about networking, and you guys have a really interesting business model where you will build out the network for commercial office buildings, and then you do all kinds of other things for them as well. So first of all, tell us a bit about yourself and Red Bison and why modern networking is so much better than it used to be.
Sure, absolutely. Thanks for having me. Yeah, so Red Bison, the bison is related to buffaloes and bisons in North Dakota, where our founder is originally from.
Nice.
But yeah, it's the company, it's kind of a network as a service company is kind of the primary, backstory to the company. I'd say it's the intersection of high-speed networks to commercial real estate, if that makes sense. And so whether it's skyscrapers, office buildings, office parks, multifamily, it could be condos or apartments. Anyway, bringing in high-speed, dual fiber, like 10 gigabit fiber into buildings, then you kind of wire up the buildings. If anybody's walked in a building and they saw those weird telecom closets or hear weird, strange terms like MDF or IDF or whatever. Anyway, there's some strange stuff in those closets. It's all about networking and building management. You'll see stuff like from Honeywell and Johnson Controls or Siemens and all that kind of stuff that make these big buildings work. And so yeah, we bring in the high-speed networks in there, then fiber and Ethernet going up through all the way up through the building and out through, all the stuff you don't see that you take for granted that's in the walls, like old stuff like Ethernet, right? And Cat6 cabling,
Right.
and then Wi-Fi access points on the end of that. Everybody thinks we're all wireless, but it's actually wireless is made of wires. Yeah, my background is mostly software. I spent most of my career at Microsoft. First half was doing Windows Mobile, Windows Phone. So I had to have really thick skin, I'd say things were okay when it was just us and BlackBerry battling it out. And then the iPhone came along and it started to get ugly.
Yeah.
And so, and then the second half was building Azure. And that was a lot of fun, building this global cloud thing and how you design that for availability. And then building Azure IoT. I have just so much background in the Internet of Things, industrial IoT and stuff like that. And so we built Azure IoT, and that was a great building, global IoT platform. Got recruited out of there by Hitachi because they wanted to build an industrial IoT platform. And so I went and did that and got to design and build the whole thing from scratch. That was a great experience. I was living in Japanese factories and
Wow.
making it real. I think that's probably where I first got into that whole weird digital twin world, modeling machines or bullet trains or all kinds of crazy stuff like that. And so you've got IoT and digital twins kind of together. And then of course you're applying analytics or machine learning, AI. And then back to networks. More recently, I was a VP over at Ericsson, which is one of the companies that makes all the cellular gear, the 5G stuff you always hear about in Sweden. So I was flying from Seattle to Sweden every month until COVID, of course. And then I'm on phone calls in weird hours of the night, because the rest of my team is in Stockholm. But yeah, so we're pulling it all together here at Red Bison. So yeah, it's pretty interesting stuff for sure.
Yeah, that is cool. And I totally see the alignment between IoT and building out the infrastructure for office towers, because you have so many objects. You got all these different routers, you got all these lights, and of course, smart cities and
Yeah,
sustainability. These are all big issues these days. Knowing what it really costs to have all these lights on, knowing what it costs to have all this stuff running, knowing how to be able to preen things or prune it down when you need to, and knowing what the impact of all that is. And that gets into these digital twins. And I'm a
yeah,
huge fan of the robust digital twin, because you can really play around with ideas and you can say, well, what if we did this and what if we did that? And you do that in your digital twin environment and you get results. And it says, okay, this is how the costs will go up. This is how the usage will go. Those kinds of things are really important for planning, right?
absolutely. And it lets you bring the whole thing to life, it makes it a living building.
Hmm.
If you think, because you're right, there's the whole bigger smart city thing, but mostly cities are made of buildings, is the primary thing. And so if you think of digital twins and kind of zooming in, it's kind of the overall property. Maybe it's a corporate campus and then one or more buildings, and then each building has one or more floors, and each floor has one or more. A lot of people are just calling them spaces now. There was this smart city, smart building. I'm hearing a lot of people kind of refer to smart spaces or sustainable spaces, maybe because they needed to genericize. Is
Right.
it an office? Is it a conference room? Is it the lobby? Is it whatever? And so you kind of have these spaces, but they're digital twins. And so each one of these spaces, you can, in the software of digital twins, you set properties for them and bring them to life. And so you mentioned, just throttling things back based on, we can have occupancy sensors. What did everybody discover during COVID? You had all these office buildings going full speed ahead with lighting and HVAC and just burning energy like there was no tomorrow, and there was nobody in them.
Right.
The buildings
That's
were
right.
empty or half empty. Even well, and today, we're kind of in this kind of in between hybrid back to work, and so a lot of times most of the people you're seeing are kind of like Tuesday, Wednesday, Thursday ish.
Right.
And so powering those buildings are one of the biggest emitters, of greenhouse gas emissions. And so if there's nobody in there, even if there is, there's ways to be smart about it. And so that network, software, IoT, digital twins, analytics, AI, building all together to make smarter buildings, but probably make sustainable buildings,
Well,
light.
yeah, and like the hidden challenge of IoT is that you have so many objects sometimes, and so it's hard to even represent visually what's happening there. And of
Right.
course, you get devices that there are so many cool things happening in the IoT space. I mean, I can't remember the name, but I had a company on here that was working in low frequency IoT, and basically I think it's blockchain underpin. You probably know who these guys are. I think they're based out of Austin somewhere. But
Okay.
basically it's like a low frequency network that can connect IoT devices with
Yeah.
very little power to the home base. And so there are really interesting things that you can do for just kind of staying on top of things. Where is the money going? Like, what does it cost to air condition this building? And what if we play around with different options on different floors and things of this nature? Even the elevators. I mean, I have to think that
Yeah.
for some buildings, strategic, intelligent elevator management is a pretty good deal, right?
Absolutely. Because you're right. Most buildings, it's still kind of mindless elevators
Right.
that are just doing like what they've done for the last 50 years, right?
Yes.
And of course, that's an even bigger thing. The reality is most buildings are just old.
Yes.
There's the world that we want, and we talk about futuristic cities and stuff like that. And we kind of joke about it. Let's say 50 years from now, when you think you're gonna have these futuristic Logan's Run looking cities, but the reality is all that old stuff that's 150 years old will also still be there amongst
Right.
it.
Right.
And, unless they're going to demolish all the old buildings, I mean, go to New York City, go anywhere, they're all still there. And
Right.
people still use old buildings. And so how can you make them more efficient, right? And so it's just like my time in industrial IoT, you're going to be retrofitting old stuff for a long time to get value. Lots of people dove into that IoT space thinking it was going to rip out all the old stuff and put in new shiny high-tech things. And that's when the guy you're talking to is like, get out of my office. I spent tens of millions of dollars for all this stuff and
Yeah.
we're not throwing it out. It's just not going to happen. But yeah, it's a good point. And so those sensors, those things, those objects, they're inside those spaces, and the space is kind of the twin. And you might be saying, well, gosh, this conference room, when there's this X number of people in here, it gets too hot, or there's too much CO2 in the air, or whatever it is you're looking for.
Mm-hmm.
You can start, there's that kind of real-time streaming data where it's telling you what's happening now, and you've got occupancy sensors and temperature and emissions and stuff like that. And then, but then you can take that same data and train models, AI models, or what we used to call last week ML. But machine learning is not cool enough, I guess, anymore. And so to tell you what's going to happen down the road, predict, oh gosh, I notice every Thursday afternoon this conference room is packed full of people and they always complain about it being too hot or whatever, and so you start using those kind of analytics to predict the future and make things better for folks. But yeah, it's an
Yeah.
interesting space for sure.
Well, and you can learn all sorts of things about yourself, about your business, about the marketplace, and just by analyzing the data, by looking at the data and understanding the usage. To your point, you can figure out, hey, for some reason, no one's ever here, or very few people are here Wednesday mornings,
Yeah,
so we don't have to turn things on as much. You don't have to get the AC cranking as much. I mean, we really are an AC overkill kind of society here in America. Like,
right.
my
You're
wife
right.
gets cold all the time, and we walk into any corporate headquarters, it's like, oh my God, it's like
Please.
64 degrees in here. And
Yeah,
I mean, I get the story about they're trying to kill the mold. Okay, I got that. We don't want mold everywhere, but still, does it have to be 64? Couldn't it be like 71, 72? It's a
it's
lot
a
of money to get spent on that stuff.
there is a lot. And it's funny you talk about being over chilled and stuff like that. When I was with Hitachi, and so I was in Japan a lot, I remember going to all these office buildings, skyscrapers in Tokyo. And in the summertime, it's a little warm in there, actually. And I'm like, what's that all about? It's that way everywhere. And it turns out they think of it in Japan as a shared sacrifice to reduce energy usage and therefore cost, right?
Hmm.
And so it's the first thing you notice when you go into these beautiful skyscrapers in Tokyo in August, and you're like, wow. And it's like they're all on board. The whole society's on board, shared sacrifice to cut costs and energy usage. And I was like, well, that's really interesting. I don't know if our country could get together here in the US to get on board with that or not.
Well, so here's the interesting thing, right? I'm a data guy, and our shows focus heavily on the data side because you want to see the
Yeah,
data. What does the data
yeah,
tell you? You have your own opinions about things, but when you can see the data, then you really understand, oh, okay, that's what it's really costing. And with a situation like you're providing with a solution like this, you can see the data and review the data and talk to people about it and see, hey, let's just test this for 5 days. Let's change the temperature from 69 to 72, and
yeah.
then watch the usage. I mean, what's cool is you're starting to see even power companies and end user facing companies embracing this. So you get your little email, here's your power usage from the last week, here's how it compares to last year or last week or whatever. And so you kind of start to get a feel for things. And the bottom line is what gets measured gets managed. And
Exactly.
so when you can show the board and your team, hey guys, we would actually save $20,000 a month if we would just raise the
Wow.
temperature up 3 degrees, and then we're going to give each of you a $500 bonus at the end of the year. How's that
Right.
sound? Like,
I love
okay.
it. I love your comment though. What gets measured gets managed. What gets managed gets measured or improved. Um, I am so on that. And I was always, when I talk about IoT, without it, you're just guessing, or you might be
Right.
making an educated guess.
Right.
But with IoT, you're knowing, you've got
Right.
that real-time data feed, and it's letting you know this is really what's going on. You're not imagining it or using a gut
That's right.
about
And
something.
it's so often I've noticed with these kinds of things, you will see things that surprise you. I mean, even though it's your office, it's your environment, you wouldn't think you should be surprised. But every time you look at some significant data set, I've found you're always surprised by something. So you're
Yeah,
going to see that outlier. It's like, well, what is that thing? Let's dig into that a bit more and understand what's going on there. And to your point, you can save a lot of money, a lot of time, a lot of maintenance. That's
right.
the other interesting thing about IoT is this
Oh,
predictive maintenance stuff. I've
absolutely.
been a I've been a huge fan of this for years. As soon as I learned about it, I was like, wow, that's cool because the engineer who has to go around and check all the doors and check all the windows and all that stuff, that's a really boring job
Right.
unless you've got some IoT solution where it's predicting, hey, this heater is going to fail. We
Yeah.
know because we recognize the pattern in usage. It goes up and it starts making a noise. And noises are a big part of that stuff too, right? Like hearing the sound,
Yeah.
uh-oh.
Noise, vibration, and it's like any industry with any kind of machines, whether you're in a skyscraper or a factory or a car, and you always hear the deal that the folks who've been working on those for years. When I put my hand on this machine, it vibrates a certain way. I know it's about to die next Thursday, you
Right.
know. And the reality is we can't rely on that forever. Those folks are going to retire. I mean, I'm up here in Seattle, and every year there's some deal in the news where like, wow, all those aircraft engineers at Boeing, they're about to retire, and no one knows how to build airplanes anymore, and we don't know how to and it's like you got to let the data tell you. You've got to start
Yes.
instrumenting everything and let the data be your guide,
Yeah.
into what you
That's
should
it.
do.
It's the instrumentation and
Yeah,
then it's the collection of all that data. And that's where maybe in the next segment we'll get more into the unwieldy nature of IoT because what you're typically measuring are simple things like temperature or amount of light or CO2 levels or whatever it is. It's some particular thing that the sensor is designed to watch for. But then again, trying to aggregate all that stuff and manage it requires some sophisticated knowledge about how to look for things like what is the pattern I'm trying to find in here. Is it when it goes down? Is it when it goes up? Is it like a variety of different things? That's what experience will tell you with the aid, of course, of machine learning in the background, because
sure.
the machine learning algorithms don't tend to sleep. They just work all night long and they do their little thing. And you wake up in the morning and they go, oh, why don't you look at this? Why don't you look at that? And I, for one thing, that's how most AI solutions are going to provide value in the future is by suggesting things to you based upon the baseline and the pattern they're seeing right now at this moment. Folks, don't touch that dial. I'll be right back. You're listening to Inside Analysis.
What if you Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
All right, folks, back here on Inside Analysis, yours truly, Eric Kavanaugh, with Rob Tiffany of Red Bison. He's been all around, worked for a bunch of big companies, Ericsson, I think Hitachi was talking about earlier, and of course, Microsoft, building Azure. That's not a small job, building out this, what is basically a cloud platform. And I often joke, the irony strikes me that Microsoft saved us from the monopoly of Amazon Web Services since Microsoft had the monopoly for years on operating systems,
Right.
and that caused a lot of trouble. I had a theory that Linux was born out of a desire to escape from that, and someone told me, no, not really, but it did serendipitously work out that way, that
Yeah.
Linux, thanks to IBM dropping $1 billion into it, to harden it to make it an operating system for enterprise solutions, and it won. And
Yeah.
now Linux is the de facto standard. And open source is teetering a little bit these days, but
That's
we wanted to
interesting.
get a bit more into the IoT stuff because I think you have to appreciate how unwieldy it is to have, like, even in a large office tower, like how many phone systems are plugged into this thing, how many HVAC systems, all these different systems are plugged in. They're all pulling on the power. And
That's
that, you want
right.
to talk about black magic, man, like really getting into power, like in these older homes, you can tell like when the heater turns on, the lights dim, it's
Yes.
because it's like, it's pulling on that flow of energy. And to
Right.
really understand that, and I'm guessing you guys got some great data and analytics on that kind of stuff, can be very compelling in terms of knowing how to save money, knowing how to provision services more effectively. And that's all really important, because when the network doesn't work, ain't nobody happy, right?
Right. You know, the network is totally a Trojan horse for us to get to do all those other great things. It really is.
I like that you're honest about that. It's fun.
It is, because I've seen other IoT players try to go after building management and do building IoT stuff, because there's a lot of great use cases there. And most of them just failed. They couldn't get into the building. They didn't know the right people. They didn't have the right, in the end, it's still about people and connections and what you're already doing there. And so, since we go in, we're giving the building something they really, really, really want. People want fast internet, and they want to be able to connect, and they need it to be reliable. And so because we do that, that gets us in there. And you can imagine, if you own the network throughout the whole building, IoT needs a network to ride on, right? And so if like you mentioned earlier, the low power, low frequency stuff like LoRaWAN and things like that, people use outside, where your IoT devices need to live for 5 or 10 years on a battery.
Right.
Luckily, in a building, we've got electricity to plug into, so we don't have to worry about that as much. But since we own the network, we've got the fastest, lowest latency network you could imagine right there. All those IoT devices, now it's easy for them to piggyback on that, and for us to get to all that data. If you think about like a pie chart of where the energy is being used in a building, it's lighting and HVAC are your two biggest culprits. And then apparently just everything that gets plugged in, all the extra stuff,
Right.
whether it's a printer or your PC or whatever, a million things getting plugged in, turns out that uses a huge chunk. And then of course there's that relationship between energy usage and emissions, right?
Right.
It kind of goes hand in hand. And so you can monitor energy usage at a building level, voltage, all that kind of stuff. But there's some great IoT sensors they have today where you can kind of do segmented monitoring of power usage in just certain parts of the building. They've got these little devices that you literally hook onto the cabling of the electricity, the power, and the ambient energy coming off that cable is enough to power the IoT device.
Wow.
And then the IoT device a lot of times is using like that low power, low frequency stuff like LoRa to send, because it's sending just little tiny bits and bytes of data, nothing major.
Right.
To you, and it'll tell you how much. And so you can do something called sub-metering, where you can say, wow, this port, this many floors or this part of the building is really a culprit. It's using way more energy than all the other guys and stuff like that. And so you get a better granular view, back to what we were talking about, the data is going to tell you what's really happening. And so instead of saying, I know the power usage for this whole skyscraper, now I have a granular view of who's using what, and you can then make better decisions, and you can do management, and you can improve the situation, or anything that flows, not just electrons, but water.
Right.
You've got water and pipes and pumps all over the building to, people are like, how is it that you have a bathroom on the 80th floor of the building? How does that work?
Right.
How's water coming out of the faucet? There's this world of pumps that's pushing water and stuff up there to make that work. I've done a lot of stuff kind of in the, reducing emissions. I don't know if you've ever heard of the United Nations Sustainable Development Goals.
Sure.
And
Absolutely.
so I built technology to, a lot of IoT to help that. Well, one of the big ones is water. It turns out I forgot how many millions of gallons of water gets leaked and lost, fresh water, every day.
Yeah.
In our cities, in our buildings. And so, and then, at some point you start to realize that fresh water turns out to be one of the most important resources we have. And so being able to monitor and find leaks where there's happening, and that whole matrix of plumbing going on throughout a building is kind of a thing.
Oh yeah. Yeah. I mean, I spent a number of years living in New Orleans, and the data on the amount of water that is lost from the facility to the homes, it's like, I want to say it's like 2/3. It's just it's a gobsmacking number, which shows you how many holes there are in the system. I mean, in my first job as a newspaper reporter, I interviewed a guy from In Situ Form, I think is the name of the company, and they would go in and use really which at the time was for cutting edge technology to go through pipes and like sense where the holes are, and they would actually line the pipes with like a synthetic material to prevent it from leaking and doing things like that. But just ask anyone who had plumbing problems, man. Like getting to
Yeah.
the bottom of that is a huge issue. And that's something that IoT can help you do if you have the sensors in place, because
Right.
you can sense the vibration, how much water is moving through here versus here. And you can use that to identify, okay, well, the problem must be here. So that's where we're going to drill through
Yeah.
your wall, like,
No, you're
cut out this
absolutely right.
piece. It's
You made
brutal.
the comment earlier of just creating a baseline
Hmm.
without even doing any crazy AI stuff, just simple KPIs. And
Right.
you say, I expect this, like, like KPIs, green, yellow, red, right? If you're in the green zone, I don't need to do anything. If I'm starting to lose water or electricity is going off or whatever it is you're monitoring, you go into the yellow and you head towards the red zone, you do pattern matching on the data, the packets that are coming in, telling you what's going on in
Right.
those pipes, in the
Right.
electricity, how many people are in the building, all that kind of stuff, and you say, I expect, kind of like in New Orleans, I expect this much water to make it from here to here.
Right.
And the reality is, well, I lost 2/3 of it. Maybe
Right.
there's a problem. And so you've got to, like you said, you've got to measure it, or you absolutely can't manage these systems. And so IoT, I often talk to folks, they think they need the most advanced technology to do IoT to compete in factories or whatever. And I'm like, just remember, you're competing with a guy with a clipboard. That's really what it is. That's who your competition is. Some guy taking logs, looking at gauges, things like that to find out what's really going on.
Right.
And so IoT is that person. It's that person taking logs, except it's continuous monitoring, right?
That's brilliant. I'm going to quote that and post it here shortly. Like, you're competing with a guy with a clipboard. That's right. Well,
It's true.
as you suggest, until you take those baselines, and let's think about it. Flow applies to water, flow applies to
Yeah,
electricity, flow applies to data, to
the
information
data.
packets going around your
Yeah,
network, right?
that's
And
right.
getting that baseline, you talk about security, getting a baseline of network traffic and what happens every day. There's a company, Anadot, I think they're based in Israel, and can't remember how they started, but they're all about anomalies. Basically, they're looking for strange
Mm,
things. Like, what is different from yesterday? Well, you don't know until you have a baseline. Once you get
that's
a
right. Mm.
baseline, then you can start analyzing and understanding. All right, now why did things slow down for this period of time? And there's a guy I interviewed, gosh, 14 years ago on the show. I love this name, Zohar Gilad. He was with a company called Precise. They got bought by who were they? They got bought by Idera, I think. And it's
Okay.
basically it's troubleshooting for
Yeah.
systems. And these days it's even more complex than that with Kubernetes and containers and all this stuff. It's like, oh my God,
Yeah.
that's why you have all this observability stuff these days, right?
Right.
But now you have to like collate all that observability data and figure that out. So it's like, this stuff comes just in time. But again, the point is understanding what's normal and then what's not normal. And Zohar, we were joking about stuff because I was saying, even if you have all this great technology, you're still looking at histograms.
Yeah.
CPU usage went up, network went down. Well, how do we correlate these things? And of course, that's where time series comes into play. It's like, well, let's look at the time series and see what was leading up. There's a slow rise here and then a big fall there.
Yes.
That's probably related, you know.
Absolutely. Absolutely.
And
You
then
know,
once, go ahead.
another thing I thought of that flows through a building and underneath every building in every city is natural gas as
Yeah.
well,
Oh, right.
pipelines.
Right.
And so it that continuous monitoring is so critical. So in real time and you can react to it, even if you're not doing predictive maintenance.
Right.
You can nip it in the bud super fast because you don't want to find out too late that there's a natural gas leak, right?
Right.
And
Right.
I saw some in the news, a house just exploded in some
Right.
neighborhood.
Oh,
You
it's
know,
so bad. Well, and
yeah,
there are sensors for everything. I mean, that's the thing about
yeah,
IoT, right? Is you get all these new kind of sensors coming out, and they're getting better and better and cheaper, right? Because
right,
a lot of
yeah,
these things are very inexpensive, and their whole job is just to go hello when something changes, right?
yeah,
But then once you get that all in line, then if you have a good IoT solution, you can save your, I mean, the cost of being able to troubleshoot quickly versus over a long period of time is massive in terms of the disparity. Like, and the, the reputational harm, the damage to human beings and to buildings. I mean, good God, water in particular, I'm sure, being in the industry, like
Yeah.
you get water leaks that go for a while, man. Oh no.
Exactly. Exactly. So you're right. Make sure you've got these little low cost leak detection sensors in the bathrooms, in
Right.
the boiler room. If there's a restaurant, there's a kitchen, there's a, whatever. So many simple things, temperature, worked with restaurants that are in buildings, and just having temperature sensors in the walk-in cooler and the freezer, I remember having a guy said, yeah, one of the, and we're not talking rocket science here, but one of the employees left open the door for the freezer as he left for the weekend, and it was going to be this closed down 3-day weekend. But luckily that sensor told him, and we're not even talking about some cool dashboards. It was just a text message. And the guy's like, yeah, it saved us, like, we would have lost $13,000 worth of food that would have gone bad just because of that.
Wow.
And then the leak stuff, you're right, is just horrible. In fact,
Yeah.
that's one of the biggest insurance companies. When they have to do payouts, you assume it's a fire is the number one, but it turns out flooding is number one. I'm sure it's
Wow.
neck and neck with fire. So I knew some guys at an IoT company, and their way to instead of charging customers to put in sensors for leak detection in their homes or buildings, it turns out when the insurance companies looked at their actuarial tables, they came to the conclusion that the insurance company, would pay for the sensors for free and everything, because the loss when it
Right.
happens is so horrific.
Wow.
So,
That's cool.
yeah, it is cool. And so a lot of times it comes back to money and insurance and figuring stuff out like that.
Well,
To
but
try
it
to,
makes a lot of sense. And that's why you want actuaries there, right? Is because they're saying,
yeah,
all right, well, if we just go ahead and incentivize people to get these sensors in place, we're going to save on the back end millions of dollars, which is probably true because all it
yeah,
takes is one bad apple to just screw the whole bunch, right?
absolutely. Absolutely. Yeah. So yeah, it's great having that network in there. I was surprised to find out that a lot of these buildings, you put in different systems, like you mentioned, elevators or HVAC or lighting. There's all kinds of systems put in by different companies. And what we've discovered over time is each one of those has the building owner install a completely separate high-speed network circuit
Interesting.
for each individual thing.
Right.
So you might come to a building and find out that this building's got 5 or 6 separate networks, all to cater to these different vendors and stuff like that. And so a lot of times we help save money for buildings by consolidating those down to, lower cost but faster, bigger pipes that way, which is kind of interesting.
Yeah, and I'll bet that, and granted, this takes some analysis and this takes some time to kind of dig into, but because you do host command and control for all these different systems, you can do time series analysis across, different scenarios. So when something happens or when a bill comes in too high or whatever, it's very frustrating if you have to look at 5 or 6 different systems. But if you can go to one master system that has control over all of them, that's where you get that single source of truth and can really kind of dig into it. And again, I have to believe that there's a lot of money to be saved by not freezing all of your denizens every day. It's 64 degrees Fahrenheit. It's like, okay, I know we want to be
Yeah.
cool, but does it have to be that cool? Like, can we just maybe ease off a little bit and see what it is? When you see the numbers, you'll find out what the deal is. But folks, don't touch that dial. We'll be right back talking to Tiffany of Red Bison, all about IoT and fun stuff. We'll be right back.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
All right, folks, back here on Inside Analysis, a fascinating conversation about networks and electricity and gas and things that flow, right? You want things that flow, like cash flow, right? You got to watch out when you get a big pool of cash, like that's when trouble starts. You want it to be flowing. You want everything to flow through your organization, energy, food, fuel, all that kind of fun stuff. And we've been talking about the networking side of that, which is a foundation of the information economy, you could argue, is networking. right? It's the ability to move information from one place to another, to enable functionality, to enable people to do cool things. And Rob Tiffany of Red Bison knows a lot about all that. We wanted to get in a bit more to the, I guess, to the edge
Mhm.
stuff. And just so people understand edge, basically your cell phone is at the edge. A computer can be at the edge. It's an edge device, basically. And we went through this interesting period of time. Client server, of course, we started with the mainframe, and you do client server, and then the cloud came along, and then you get hybrid cloud and multi-cloud and all that stuff. And then the edge comes along. The edge is very, very interesting because it's not the data center per se. It's not like the big corporate data center. It's not the cloud. It's not just one device. It's all these devices that are out on the periphery, basically. But you could do interesting things there. And you were talking about this earlier, Rob, where you come in, you build a network for the office tower. And by the way, we now have servers on every other floor, so we can do a little mini cloud for you. You don't have to send stuff up to the cloud, because what happens when you're sending everything up to the cloud? You got to go through the network.
That's
Right. I
right.
mean, I was in the Hadoop space, which was a big deal.
Yeah.
You may remember Hadoop. And
Yeah.
the network was the Achilles heel, because you had to move all this stuff around the network. And so all of a sudden that becomes the bottleneck. And anyone knows in business, as in life, bottlenecks are where you have to figure out what to do. And you guys
Yeah.
have done some interesting things on that. So tell us about how
Yeah.
you're able to enable all sorts of interesting services for your clients.
Yeah. Well, since we don't just install the network and walk away, we kind of do this network as a service. So we're actively
Right.
managing it. We have hardcore firewalls all over the place. We've got AI built into our networking gear. And so we actively manage. And so that's an ongoing thing that we do to make sure performance is always there, to nip things in the bud, like we talked about with other things.
Right.
Security is the huge deal. But just make sure, a customer's paying for this much bandwidth, we have to make sure that they're getting it. And so actively doing a network as service then gives us the ability to go in and provide other services and have that confidence. Because you're right, you talked about Hadoop and the network bottleneck being an Achilles heel for a lot of that stuff. So since we have this crazy network that we're managing actively, so you walk into a skyscraper and every floor there's this weird door that's like a closet. Do you remember the good old days when companies used to put their IT stuff in a closet, kind of
Yeah.
servers?
Like literally in the closet. Yeah.
In a
Oh, yeah.
closet, before data centers got big or anything like that, there was the IT closet or whatever.
That's right.
Okay, that still is kind of here today, believe it or not. And so the bottom floor, I don't remember what the acronyms stand for, but the bottom floor is called an MDF, and that's where the fiber optics comes in. That's where all the building management stuff is. And then on the subsequent floors, they're called IDFs, and they're smaller. So since we get space, since we own the network, we get space, rack server space on every other one of those floors to put compute in there. And so you kind of ask the questions, well, gosh, so we have cooling, we've got electricity, we've got compute, it's right there. It's inside the security envelope that we've created.
Right.
Like, so you're inside the building and you're protected by our firewall, and we're actively managing it with AI systems. And so you've got an interesting scenario where, and to your point, there's all kinds of edges. I used to think I knew what edge computing was in the early days of IoT. It used to be like a rugged PC talking to machines in a factory. And then the sensors and devices themselves got powerful enough that we did compute there right at the very, very edge, right where
Right.
the endpoint almost,
Right.
and so what we're able to do, and then gosh, there's companies that are doing edge computing, like literally taking shipping containers, like cargo shipping containers, and packing them full of servers and dropping them in some place in a city and hooking them up. And so the edge thing is super disruptive to the cloud. It's also probably collaborative as well. And so lower latency because it's closer to the source of the data or the
Right.
people who
Right.
need to use that stuff. So since we put this edge compute, we are users of it, and then tenants in the building or the building owners are also can use that. And so I'd say our first product offering around that was a real no-brainer was security cameras. Turns out lots of buildings, lots of people are into having, different security
Right.
cameras around their thing. It's
Right.
kind of a thing these days, especially it's booming these days. I hate to say it.
Right.
It's good for business, but it's bad for society that we need more security cameras. And so normally you'd have all these, that the rise years ago of IP cameras, and all these standards to stream HD video and record it and do playback. And so a lot of folks are just streaming it off to AWS or Azure or GCP, some cloud, and they're paying whatever for storage up there. So since we have this edge compute, we're like, well, you're in the building, you could just stream all those HD streams to us, and we have massive, hundreds of terabytes of storage locally on site with our edge compute. And so it's a low latency, high speed way to get that stuff saved and recorded and then playback really quickly. And then if you want to tie in all this crazy AI stuff to it, you're seeing more and more computer vision where it can actually recognize what's going on, or is this a person, or that's a cat, or this person went from this place to this place, or whatever, And so folks are interested in that. So that's a good use case. The same kind of business workloads you might run in the cloud, like there's the standard, I need to spin up a VM and I need so much storage to run this business workload.
Sure.
We do that at the edge. As it turns out, without having to buy the edge versions of Azure or AWS, they'll have special fun names for those kind of things and having to pay them for that. Turns out there's lots of great open source solutions. Back to, you were talking about Linux, based on Linux, me being spending so much time in the telecom world, all the telcos, a lot of them are using, what is it? OpenShift, which is Red Hat. There's OpenStack, Canonical, Ubuntu, Linux, those guys.
Yeah.
They even have a smaller version that we've utilized. It's literally, I think it's just called microcloud. And so you can imagine being able to take a few nodes. It works with as few as 3 nodes, 3 servers basically, and it'll create a cloud instance and it'll cluster together storage and everything dynamic. It's so much easier than it used to be when we had to really do this by hand.
Yeah.
And then providing kind of that web interface. And now we're providing it just to people in the local, building. And then they can click and say, yeah, I want to spin up a VM that's using 2 virtual CPUs and this much RAM. And I'm going to run my workload right here in the building. And it's going to be cheaper. It's going to be lower latency. It'll be more responsive, that kind of thing. Or I just want to do storing data, backup data, like you might do to the cloud, or to, obviously there's no shortage of cloud-based backup data services out there.
Right.
They can do stuff like that as well. And so they can run workloads. We'll run our IoT stuff is running at the edge in the building and talking to all those sensors and all those building systems at high speed and low latency. And so it's kind of a win-win for both of us. And yeah, customers are all, a lot of, I'm surprised there's still people doing IT closets today.
Yeah.
And they're like, can you
That's
be our
too funny.
IT closet?
Right.
Yeah.
Well, and I mean, I'm guessing that you have enough analytics from some of the instances that you have to be able to do some consulting on this stuff, to be able to say, hey, you should put this here, put that there. I mean, data centers, for example, knowing where to put stuff in the room is pretty important, and being able to track where the airflow goes. You have your hottest machines right underneath this, particular air duct. I mean, there are specific things that you can do that take a lot of attention and take a lot of effort to focus on. And it's so important because it's very expensive to run these big buildings. And it really helps to be able to know, what does this cost? What are our options for being able to achieve this in some different way? And just having another competitor to the existing cloud service providers is also good stuff. Like, just because you'll see there's certain use cases where you really want that very, very low latency. If you're doing a data science project, for example, or experimentation, PII, there are all these different use cases where it makes sense to not go up into the cloud. And you guys are giving an option for doing all that, right?
It's just another option. There was that notion, I think a lot of us felt like, with the growth of the hyperscale clouds, that the data center business was going to go away. And it turns out the inverse has been true. They're building data centers like there's no tomorrow. And as soon as they open, they're being sold out, packed full of servers. 5 years ago, they were doing Bitcoin mining. Now they're all AI training factories.
Wow. And by the way, Helium was the company I was thinking of. The guys from Helium, they're the ones that do the low frequency. I mean, that's just so fascinating to me, using low radio frequency to communicate an IoT devices. Well, folks, look this gentleman up online, Rob Tiffany from Red Bison. If you're in the commercial property space, you want to be talking to these guys, folks. You've been listening to Inside Analysis. Okay, folks, time for the podcast bonus segment here on Inside Analysis. A great show with Rob Tiffany from Red Bison. And you threw out that great segue at the end of the segment talking about training AI. And there's a company called Hammer Space. I was on the girls' show a few weeks ago. They're actually training Llama 2 right now. So that's pretty interesting. And she was talking about how there are shortages of processors. Like you can't even get the processors because everyone wants them because all these companies are trying to train AI. And, you know, frankly, I know for sure that these AI models are going to fundamentally change computing. You know, as I look at, you know, like, for example, when ChatGPT was unveiled, like in April or something, or May, I started playing around with it. Within 5 minutes, I was like, oh, if it can do all these languages, I bet it can do code too. Yes, it can.
Yes, it can.
Right. And it's like we had the show last week on this, and they're just talking about Osama Fayyad, who was the chief data officer for Yahoo, was saying, yeah, really scientifically, there's not that much that interesting about these. They're just weights. They're just weights, and it's a predictive engine. But it has so much information that it is absorbed. And yes, they do hallucinate. Yes, there are these issues, but I think they're going to figure out a way around all that. And I think what you're going to see is a whole new generation of software applications built on top of these things. And guess what? A company like Red Bison, because you are running the network as a service, you're very well positioned to do these sorts of add-ons and to basically come in and say, hey, guess what? We have this new service where we can help you train your own private instance by using all this data that of your usage of what you've done over the years. I mean, there's all these things you could do if you have the data, right?
Absolutely. Absolutely. You know, you're right. Nobody can find those NVIDIA GPUs that everybody wants. I mean, I guess NVIDIA was the biggest number one stock performer in 2023.
Yeah.
Because everybody wants what they've got to train
Right.
AI models, and it's going crazy. And so, you know, being able to, but I think you're also seeing AMD is starting to get some love. Intel had to recognize that they need to get in that game, and there's been a lot of talk in the last few weeks about AI PCs and putting neural processing units in just kind of desktop or laptop class devices. And so we take advantage of GPUs, you know, and our edge compute so that we're training models ourselves. And, you know, and actually to your point about writing code, as I've been building a lot of technology, I've been using it as an assistant, you know. Like I've used ChatGPT and I've used Microsoft's Copilot, and they've integrated Copilot in with GitHub.
Right.
And so, you know, when I have to, if there's some tough problem you're trying to solve, you'd be amazed of how good it is at figuring out, you know, complicated scenarios or algorithms and stuff like that. And so it's helped me to build software that does AI. Your ability to not just have to use AI training software that's in the hyperscale clouds. There's a lot of stuff you can do locally. You know, you can use Python. I've been using a technology from Microsoft called ML.net. So you know the .NET framework and C# and all that stuff in that world. They've built a AI training system that's like, and you know, Microsoft tries to make things easy, which is great, helpful to train models using a .NET and C# versus Python or R or something else. And so and you can do it locally. And so we can have that technology to train models right there locally at the edge for folks. We can do it for ourselves. We can do it for tenants. But you can imagine doing it for third parties who aren't even in the building.
Right.
Like when I think about how I'm designing our edge cloud, basically, is taking a lot of the ideas we had at Azure and at AWS had this notion of availability zones. You know, you always want to have uptime and availability. So you can imagine now that MDF on the first floor might be the main place, but those other closets above there, those are availability zones where we replicate data across so that different things can go down. Because the cloud's designed for failure. You know, servers are failing continuously, but the software keeps it going.
Yeah.
And so we start there with availability zone. That way, the next step for us will then be in the same city where we have other buildings replicating across that, and then regionally. So just like, you know, So yes, I'm sure you'll say, yeah, I remember when I talked to some guy at Red Bison and they ended up taking down all the hyperscale clouds just quietly as they, thing just came to life, and it was in every building on every city in every country.
That's wild.
It is
You know,
wild, but there's
you
a
know,
demand. There's a demand to train AI models by people, and people are looking for compute wherever they can get it. And so
yeah,
data centers are being built as fast as they can. And so that's kind of how I think of our edge cloud. It'll do
that's
some of that edge IoT stuff, but we'll use it for other things as well.
well, and you hit the nail on the head when you mentioned how they're just filling up immediately. So, I remember I'll close on this, but I remember interviewing a guy from the Illinois Department of Transportation like 30 odd years ago in my first job. And he made a really interesting point. He said, the law does not allow you to plan the size of a highway based on projections of future traffic. You have to look at existing traffic as your baseline and then build the highways. And he said that's a bit of an issue for us because as soon as we build these big 3-4 lane interstates, boom, they're filled. And they did that in Illinois with I-355 because you've got 55, which is a major highway, but just gets clogged as heck getting into Chicago. But they built 355, and I mean, within days, it was just packed with cars because now you could
Yeah,
go all the way up to the north suburbs in like 32 minutes when it used to
yeah,
take you an hour and a half. So you'd go see your friend up in the north suburbs. You'd go shopping to different
yeah,
malls and things like that. So people use stuff when you make it available. Then you got to, and the other thing with the data centers is that you reach the end of the data center. You cannot get one more box in that data center. That's where the edge comes into play. Because if you got a bunch of these little edge nodes, then guess what? You can very quickly absorb the demand and take their money and make good things happen, right?
that's the plan.
I love it. Well, look these guys up online. What a fun conversation with Rob Tiffany of Red Bison. Send me an email if you want to be on the show, info@insideanalysis.com. We'll talk to you next time. You've been listening to Inside Analysis.